Okay. The next thing we're going to talk about is the communication between neurons, your axons and stuff, action potential. So how do neurons talk to one another, right? The action happens at synapse, and in case you were wondering how that looks through the vicious drawings of my brother, here's how it looks, right? So this is one neuron and this is the terminal of the other, and that's how they're communicating. This little dot is here, this is the current that they're sharing, aka the impulse that we have, and that's how we talk. So we have two processes that talk about synapse, right? So it's the presynapse and postsynapse. The presynapse is the axon that's the axon that's sending the signal to communicate with another one, and the postsynapse is the one that's receiving the message, right? So in other words, at synapse, the firing of an action potential to one neuron to another is the presynaptic, aka the one that's sending the neuron the signal, causes the transmission of a signal to another neuron, the postsynaptic or receiving neuron, making the postsynaptic neuron either more or less likely to fire its own action potential. So you send one action potential to another action potential until you do raise your arm or move away or whatever it is you're trying to do. Now this is how that looks. So this is one action potential going from the presynaptic cell right here. This is the sending one. Synapse happens between them, and then the postsynaptic receives the message and potentially sends it to another one. So married to my brother to this drawing again. And why is this important? So say for example, I'm gonna throw a ball at you right now, or somebody's throwing a ball at me. So I'm looking at it and I see I'm not gonna be able to catch it with my hand first. So I'm gonna have to try to protect my eye. So first I'm looking at it, and then when the ball's about to hit me, all I do is close my eye, because that's the only way I can protect my eye. This is important because that's a way of, it's just not only a protecting mechanism, but it's more than that. It's everything. It's a way to react, it's a way to create reflexes, which is the next thing we're gonna talk about, right? So what is a reflex? It's a response to a stimuli, pretty much. So here I have, your spinal cord usually controls these reflexes, and a reflex is the action that often involves a very simple nervous pathway called the reflex arc. And the reflex arc starts off with the receptors being excited, so it can hear or your eye or whatever it is that's being excited at the moment. And then it sends signals along the sensory neuron to your spinal cord, and then it's passed on to the motor neurons, and then your response, poof, you do whatever it is you were intending to do, right? Now we know that there is two types of reflexes, and that is your monosynaptic or your polysynaptic. Your monosynaptic is the one that uses one sensory neuron or one motor neuron only. So when you go to the doctor and they tap on your knee and then they hit it and it right away moved, that's monosynaptic. When you do polysynaptic, you do more than one. So you were not expected to do anything, so you hit the nail at the bottom of the table, and then you moved up, and then you flexed the rest of your arm, and then you created 1, 2, 3 movements just to push away from that. They both use different parts of your brain, and in my experience, I think the poly are the ones that we use the most because they are involved with all our day-to-day functions, right? That's the most important aspect I can think of for reflexes, because they're your triggered actions. But like a reflex to having your eyes dry is to blink, and then that's obviously another reflex there. Or another reflex you have is to see something and you're gonna grab it, that's another reflex there. But that's it. Thank you so much, everybody.